Hi everyone! Last time we investigated improper fractions where the numerator was larger than the denominator, and that improper fraction was larger than one whole. In the video before that, we learned that a mixed number is also larger than one whole. Today we'll see how we can convert our improper fractions to mixed numbers and mixed numbers into improper fractions. First, let's look at this diagram as an improper fraction. We know that our numerator tells the number of shaded parts and the denominator tells us how many equal parts. We also know that our numerator will be larger than our denominator. So let's count our shaded parts. We have 1, 2, 3, 4 shaded parts. Now, how many equal parts is our shape divided into? It's divided into 3 equal parts. So our denominator is 3, and our improper fraction is 4/3. Now, let's look at this same design as a mixed number. Let's see how many wholes we have and how many parts of a whole. We can see that we have 3 shaded parts out of 3 equal parts in our first circle, which is 3/3. This is equal to 1 whole. In our second circle, we have 1 shaded part out of 3 equal parts. This is our fraction part. So we have 1 whole, and 1/3. This is our mixed number. Now, is the improper fraction the same size as our mixed number? Pause the video and think about it for a minute. Let's look at some more examples. How many equal parts are our circles divided into? Well, if we count them, we'll see that there are 8 equal parts, and we know that's our denominator. How many shaded parts do we have? Well, we have 8, 16, 24, and an extra 5. So altogether we have 29 shaded parts out of 8 equal parts. What about the same diagram as a mixed number? Well, we can see we have 1, 2, 3 wholes, and then 5 out of 8 in our last circle. So our mixed number for this diagram is 3 and 5/8. Let's do the same thing for our rectangles. How many shaded parts do we have? Well, we have 1, 2, 3, 4, 5, 6. So we have 6 shaded parts, and we can see that our shapes are divided into 4 equal parts. So our improper fraction is 6/4. What about the mixed number? Well, we can see we have 1 whole, which is 4 out of 4, and 2/4 in the second set of rectangles. So our mixed number will be 1 and 2/4. Now notice the size of our shapes hasn't changed at all. We're simply using 2 different names to represent the same amount. But what if I get really big numbers and I can't draw it out? Let's do some examples. What if I had 48/3 or 37/5 or 94/6? Well, we're certainly not going to take the time to draw all those shapes out. So we have a faster way. Let's take a look at the improper fraction 15/4. How many wholes can we make? We know that 4/4 equals 1 whole. Let's pull some wholes out of our fraction. So we can have 4/4 plus another 4/4 plus another 4/4, and now we're up to 12/4. Do we have enough to make one more whole? We don't. That would need 16 wholes, or 16 shaded parts. Our numerator says we only have 15. So we can only add 3 more fourths to get from 12 to 15. Our mixed number will be 3 wholes and 3 fourths. Let's do the same thing to 7/3. How many wholes can we pull out of 7/3? Well, here's 1, 2. So we're up to 6 in our numerator. We need 7. We can only add 1 more. So we get 2 wholes and 1/3. This still takes a bit of time. There is an even faster way. If we go back and look at 15 fourths, notice that the fraction bar, this line right here, is actually a symbol that means divide. So if we find that we divide 15 by 4, let's do that. How many times does 4 fit into 15? We know that it fits 3 times with 3 remaining. So we have our 3 wholes, our 3 remainder, and our denominator stays the same because the number of equal parts does not change. So that's a much faster way than pulling out wholes or drawing. We can simply divide. What about changing mixed numbers to improper fractions? First, we have a mixed number that is 2 3/4, which means 2 wholes and 3 out of 4. Our denominator is 4, so we know our shape would have 4 equal parts. I'm going to draw this one just to illustrate what I'm saying. So how many shaded parts do we need to make 2 wholes? So our first shape is divided into 4 equal parts, and I will shade in 4 of them, but that is only 1 whole. So I will make another bar, and then I'll shade in another hole, which is another 4 out of 4. That is only 8 so far, and I only have 2 holes. I need 3 out of 4 as well. So I'll make one more bar and shade in 3. And there's my 3 out of 4. So if I count up all my shaded parts, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my improper fraction is 11 out of 4, or 11/4. Let's try another one. My next one is 1 5/6, 1 whole and 5/6. So I'll draw my bar, divide it into 6 equal parts, and shade in 1 whole. 1, 2, 3, 4, 5, 6. So there's my 6 out of 6, which is 1 whole, but I need 5 more. So I'll draw another bar and divide it into 6 equal parts and shade 5. 1, 2, 3, 4, 5. 5, 6. So how many shaded parts do I have altogether? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So my improper fraction is 11/6. Now this is still a little time consuming, so let's go back to our first mixed number and I'll show you a faster way. My first mixed number was 2 3/4 or fourths. Now notice, if I multiply my denominator times my whole number, let's do that, I get 8, and then I'm going to add my numerator, and I get 4 times 2, which is 8, plus 3, which is 11. And my denominator stays the same because the number of equal parts in each shape did not change. So notice, I got 11/4 which is the same as that I got up there when we drew it out. So if we multiply our denominator times our whole number and add the numerator, we'll get our improper fraction, in this case 11/4, a much faster way. Here is a reminder of how to change an improper fraction to a mixed number. Divide the numerator by the denominator. The remainder is your numerator, so it goes over the denominator. Your denominator doesn't change because your equal parts has not changed. And here is a reminder of how to change a mixed number into an improper fraction. We multiply our denominator times our whole number and add the numerator. Again, the denominator doesn't change because the amount of equal parts has not changed. Rewatch this video as many times as you need to feel comfortable with the material. Bye for now.